Problem 111, minimum depth of a binary tree. Given a binary tree finds its minimum depth, the minimum depth is the number of nodes along the shortest path from the root down to the nearest leaf node. So a leaf node is a node with no children. Okay, so there are at least two approach, which are DFS and BFS. Since we can utilize the early termination for the reason of early termination. We will implement BFS. Okay, so for BFS, of course, for the trivial case, is that the root is itself a null pointer. Okay. Okay, then we will return 0. Done. Otherwise, we will initialize the queue for BFS. The data type is std queue. Each element in the queue is a pointer to the tree node's data type. Data type. Okay. Queue. We also will initialize the minimum depth. Okay, and initialize it to be 0. Alright, so I'll start BFS. Well, okay, and of course we'll push the root node into the queue, right? Okay, as long as the queue is not empty, and not empty, we will do the following. Okay, the queue is not empty. We will do the following. What's the, let's see, BFS. Okay, let's see. Okay, for each node in the layer, we are okay. If it is not empty, we will do what? We will examine each node on the same depth. Okay, the queue is not empty, so we will examine each node on the same depth, and we will declare a variable which is n. Size is the number of nodes on the same depth. Okay, so and since we don't forget for each iteration we will increment our depth. the depths by 1. Okay. So for all the nodes on the sand depths, okay, we'll do the following. Well, first, pop the node out. Okay, pop the node out as the current node. Okay, q dot pop. Is that it? Oh no. Let's see the reference. Where pop. Oh, we just need to access it. Access it. Nope. Front and pop. Okay. And then we will examine whether it is a leaf node. A leaf node, by definition, is a node without children. Okay, so if its left and right child does not exist, current node, its left is null pointer, and its right is also null pointer. Then it's a leaf node. So by definition we will return the depths because it is the nearest leaf node, right? Here, let's see. Okay, return this. Otherwise, it is not a leaf node. Then we'll push the child nodes, maybe it's plural or singular, not sure, into the queue. Okay, so if it has a left node, left child, then we'll push the left child into the queue. So in the same manner, we will push the right child into the queue. Push this one. Okay. So this is basically BFS. Okay, right. Okay. So, and don't forget the child node will be examined in the next iteration because the child node will be on the depths incremented by 1. Is it okay? Let's submit it. Okay. Okay. It's an all control path. Let's see. For cube pop, cubed push. Okay, is it return? Not sure. Maybe it's some kind of erroneous. Okay. Okay. Oh, another way is to use DFS, right? Another way is to use DFS. Okay, so DFS basically recursive. Minimum depths. Let's see. Subtree of the current node. Okay. Okay, let's see. We will just this one. Right. Okay, right. And similarly, left. Don't forget, if it's a null pointer, it will be 0. And so that's for DFS. Condition 1 is that current node is a leaf node. Okay. Condition 2, current node only has a child. Condition 3, condition 3, current node has both right, left, and right child node. Okay. If current node is a leaf node, okay, then meaning that let's see, right, left, meaning that if okay, left equals to 0, mean that it it does not have the left child. So why? Okay, else it has left child. Okay, if I don't want to be too nested. Just condition 1. Okay. Let's see. For readability, just if and right, then just return the current depths, right? the current tabs. Let's see, return, 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 return. Okay, we need to figure out how to deal with the tabs here. Okay, only has a child. Okay, let's alternate. Alternate this, then we will return the minimum depths. Okay, minimum depths of the left and the right, and don't forget to +1 because we need to add the current node, because the depth is the number of nodes, right? Subtrees. Okay, and one represents bad notation count for the current node. Okay, so the condition tree will be it's a leaf node. Leaf node. It's a leaf node. It's a leaf node. It will return 1. Is that correct? Okay, yes, because the leaf node. The leaf node itself is a node, so the number of nodes will be incremented by 1. The last condition is that current node only has a child. So if it has a left child, then we will return then we will return the minimum depth of the left subtree. The minimum depth of the left subtree. Left subtree. Left subtree. Is that correct? No. If left equals to 0, meaning that it does not have left child, so we will return right. Okay, and don't forget to +1. Okay, and vice versa. If okay, right +1 +1. Is that okay? Should be okay. Not sure. Okay, accept it. Okay, that's it.